In this video, we're going to be looking at the first 7 problems in the Exam 1 study guide. So let's go ahead and get started. The number 923,187,456 is called a pan-digital square because it uses all the digits from 1 to 9 once each and is a square of a number. Round the pan-digital square 923,187,456 to the nearest thousand. Okay, so this is a rounding problem, and let's go ahead and write our number here just a little bit bigger so we can look at the place value. 187,456. Okay, so this problem wants us to round to the nearest thousand. So let's look at the thousand place, which is going to be right here. And per rounding rules, we look to the right, and if this digit is smaller than 5, then this digit will remain the same, and the rest will become zeros. So our new number becomes 923 million. These are all going to stay the same. 187,000. This digit remains the same, and these will become zeros. Perfect. Okay, awesome. Round the number. Same thing here. I'm going to go ahead and write this a little bit larger. 18. To the nearest thousandth. So this means that the decimal, the place value in question is going to be after the decimal. So this is the thousandth place. So we look to the right, same thing, and we see that this digit is smaller than 5. So this digit will remain the same, and these will become zeros. So we've got 18.654. And because these are zeros, we don't have to write them in this case. If we had zeros over here, we would need to write them, but if they're after the decimal place, we can just leave them off. Okay. Select the best estimate for the distance traveled by a truck traveling at an average rate of between 40 and 50 miles per hour for 3 to 4 hours. Okay, so I notice here that it asks for the best estimate, so we're not going to end up with an exact answer. But let's take the average speed, and then let's also take the average time that the truck could have been traveling, and let's see what we can do with that. So let's start with the speed. So the truck could have been going 40 miles an hour, and it also could have been going 50. And let's divide the two to take the average. So we've got 40 plus 50 gives us 90. Divided by 2 is going to be 45 miles per hour. Okay. Same thing down here. Let's take the average of the 2 times. So we've got, could have been going 3 hours. Oops, sorry there. So could have been going 3 hours or 4 hours. And we're going to divide the 2. We get 3 plus 4 gives us 7. Divided by 2 gives us 3.5 hours. Okay, let's take a look at what we have here now. So we've got 45 miles over 1 hour. And when we do conversion rules, we want to make sure that we cancel our units. So we've got hours down here, we've got hours over here, so let's put out times hours on the top. 3.5 hours. Okay, so hours here will cancel, and that's perfect because we're left with miles, and all of our answer choices are in miles. So this works out. Now the last step that, well, almost the last step that we have to do, we need to multiply 45 miles times the 3.5 hours. And when we do that, we get 157.5 miles. Now, I'll remind you that the question is asking for the best estimate. So this is probably not going to be any of our answers, as you can tell. But what we can do is we can round this answer to see if any of these will match. So let's round it to the nearest. Well, these are all rounded. We can see most of them are rounded. Which one do you think? Yeah, exactly. B. This one's going to be rounded to the nearest tens place. So sometimes it's helpful whenever you have multiple choice and just to see what they're rounding to. Okay. What necessary piece of information is missing that prevents solving the problem below? A steak sells for $8.15. What is the cost per pound? Okay, so we've got two variables here. We've got cost and pounds. And they already gave us the cost. So what else do we need to know? Exactly. The number of pounds. And when it says per, that's a word indicator that we would be dividing. So we would take the cost of the steak divided by the number of pounds that they bought. Okay. You have $250 to spend and you need to purchase 4 new tires. If each tire weighs 21 pounds and costs $42 plus $2.50 tax, how much money will you have left after buying tires? Okay, so let's start with how much money we have. So we've got $250. And they want to know how much money we're going to have left. So let's figure out how much we actually spent. Now, it says here if each tire weighs 21 pounds. Well, in the question, they're asking about how much money. So we don't really care about how much each tire weighs. So we can just X this information out. It's extra and we don't need it. But we do know that we need to buy 4 tires. So we're going to subtract from the money that we already have. And if we have 4 tires, each one costs $42 plus $2.50 tax. So total for 1 tire, that's going to give us $44.50. Now, how did I get that? I simply added the 42 plus the $2.50 tax for each tire. And then we multiply that by 4 because we need 4 tires. And this will give us how much money we have left. So, per our order of operation rules, we need to multiply this 4 by what's inside the parentheses. And when we do that, we get 178. So let's start from the beginning. 250, keep this negative sign here, minus 178 equals x. Okay? And I like our problem a whole lot better now. All we have to do is subtract. And 250 minus 178 gives us x equals 72. Perfect, and that's going to be $72. This is going to be the amount of money we have left after buying the 4 new tires. Which is the better value? A 12-ounce jar of honey for $2.19 or an 18-ounce jar of honey for $3.45. Okay, let's let's have a little face off here. All right, let's start with the 12-ounce jar. So we're going to do the cost per ounce. So let's start with the 12-ounce jar and we do $2.19. And here I'm not going to do our answer in dollars. Let's make it into cents. So I took out the decimal. So this is going to be 219 cents divided by 12 ounces. This will give us the cost per ounce. And I'm going to set up the same thing over here for the 18-ounce jar. 345 cents. It's the same amount divided by 18 ounces. Okay? And so for the one on the left over here, when we divide, we get 18.25 cents per ounce. And when we divide over here, 345 divided by 18 is going to give us 19.17 cents per ounce. The better value is going to be the one that costs the least, so it's going to be the 12-ounce jar of honey. And fun fact, when you're at the grocery store, I'm sure you've seen this, but they usually have this on the label really, really tiny below a product, just so you can get a better gauge of the value of what you're about to buy. It's kind of helpful. Okay. An automobile purchased for $34,800 is worth $9,800 after 5 years. Assuming that the car's value depreciated steadily from year to year, what was it worth at the end of the second year? Okay, so let's start with the value of the car when they purchased it and find how much total the car depreciated. So to do that, depreciate means that the value of the car is going down. So we can take 34,800 minus what the car is worth at the end of year 5, and that will give us how much the car went down in value. And when we subtract that, we get $25,000. So now from this number here, we want to figure out, since the car's value was depreciating steadily, that means the same amount each year over 5 years. So that means we can take the amount of money it depreciated, divide it by 5 years, and see what we get. So 25,000 divided by 5 years gets us $5,000 per year. All right. So now they would like to know what was it worth at the end of the second year. So after 1 year, let's see. So when they bought it, it was worth $34,800. After the first year, what was it worth? So we can do 34,800 minus 5,000 gives us 29,800 at the end of year 1. We can subtract another 5,000, gives us at the end of year 2, which is going to be $24,800. This is going to be how much it was worth at the end of year 2. Awesome, awesome. This problem says use rules of divisibility to determine whether 89,001 is divisible by 2, 3, 4, 5, 6, 8, 9, and 10. Okay, so let's take a look at our divisibility rules. So for the number 2, I'm just going to make a list over here of whether they're divisible, and then we can work through the other ones. So 2, 3, 4, 5, 6, 8, 9, 10. Okay. And this is our number here, 89,001. So how do we know whether something is divisible by 2? Well, 2, it needs to either be, the last digit needs to be even or 0. Or 0. And this number is a no. So it's a 1 and it needs to be, so I'm going to write an X there. It's not divisible by 2. 3. How do we tell if something's divisible by 3? Well, the sum of the digits needs to be divisible by 3. So the sum of all of these digits needs to be divisible by 3. So we've got 8 plus 9 gives us 17 plus 1 gives us 18. 18, is that divisible by 3? Yes. Gives us 6. Awesome. So I'll write this here. Sum of digits divisible by 3. Okay, 4. What do we think? 4, the last two digits need to be divisible by 4. So we've got a 0 and a 1, and that's also going to be a no. Alright, so I'll write this out for you as well. Last two digits divisible by 4. Alright, 5. This one's pretty simple. The last digit needs to be a 5 or a 0, which is no. Last digit 5 or 0. And I'm writing these out here for you so you can add them to your notes for review purposes. Alright, 6. What's the rule for 6? If the number is divisible by 2 and 3, then it's going to be divisible by 6. So let's write divisible by 2 and 3. What's good about this one is that we've already determined whether or not they're divisible by 2 and 3, and this one is also a no. Okay? 8. The divisibility rule for 8 is if the last 3 digits are divisible by 8. Last 3 digits divisible by 8. And that's also going to be a no, because 0, 0, and 1. Okay, what about 9? The divisibility rule here is if the sum of the digits are divisible by 9. Of digits by 9. So we've got 8 plus 9 gives us 17, plus 1 gives us 18. Is that divisible by 9? Actually, yes. Perfect. Okay, and last one here, 10. If the last digit is a 0. And that's also going to be a no. Awesome. So go ahead and feel free also to add these to your notes. I think these are good to practice with, and they're come in quite handy whenever you're working in the middle of maybe a word problem or something. They'll be really helpful. Find the prime factorization of 180. So let's start with 180, and we're going to do what's called a factor tree. I'm sure you guys have seen this before, so let's start with 18 and 10, since that's an easy one. And we can do 10 over here is going to be 5 and 2. 18 is going to be 9 and 2. 3 and 3. So we can write this out as these are all the prime numbers that you can multiply together to get 180. It's going to be 3 times 3 times 2 times 2 times 5. Find the greatest common divisor and the least common multiple of 220 and 400. Okay, so let's start with 220. So we've got 2 times 110, 2 times 55, and 5 times 11. Okay, all we did here is create a prime factorization tree. We're going to do the same thing over here for 400. Now I know they're asking for greatest common divisor and least common multiple, but both of these factor trees are going to help us get there. So 2 times 200, 2 times 100, 2 times 50, 2 times 25, and 5 times 5. It's a long one. Okay, so let's look at how we find the greatest common divisor. Greatest common divisor is going to be the ones that are in common. So I'll show you. So here we've got 2 times 2 times 5 times 11. And here we've got 2 times 2 times 2 times 2 times 5 times 5. Okay, so to find the greatest common divisor between these two sets of repeated multiplication here, we're going to take what is common out of these two. So what we've got is the 2, and the 5. The 2, and the 5. Okay, so the greatest common divisor is going to be 2 times 2 times 5, which gives us 20. Okay, and then the least common multiple is going to be the greatest common divisor, so 2 times 2 times 5 times 2 times 2 times 5 times 11. Because that's what's remaining. So when we took out these for the greatest common divisor, we're left with what's remaining, and that's what we have to multiply by here as well. And when we multiply all this together, we get that our LCM, or our least common multiple, is 4,400. Add -17 plus parentheses -17. So when this is in a parentheses here, this is still, you're still adding -17. So question, will our answer be negative or positive? Well, it's negative, because if we're already negative and we're still adding another negative, we're going to get more we're going to go more negative. Or if you think about it on a number line, and this is 0, got -17 over here, and we're going to get more negative by adding more negatives. Our answer is going to go this way. So we end up with -34. And when you guys are doing this, you can do this by hand, and then you can always check it on your Desmos calculator. That might be a little bit of a helpful way to double check yourself. Okay, what about 9 minus 20? So we've got a subtraction sign here, but it's before the bigger number. So is our answer going to be positive or negative? Well, it's going to be negative because the negative sign's in front of the bigger number. So, 9, it's helpful for me if we think about this on a number line. We'd have a 0 here, and we're already at 9. We're going to subtract 20, and we go to 0, and then we're going to come all the way to a negative 11 if we subtract 20. This right here is going to be 20 units in this direction. So it will be negative 11. And same thing here. Feel free to use Desmos to check your answer. Okay. Multiply parentheses negative 8 times parentheses negative 5. Okay, so when we're working with multiplying integers, a negative times a negative is a what? It's a positive. Yeah, very good. So this is going to be 40. Now if we had, let's say we had negative 8 times positive 5, that's going to be a negative answer as well. Or rather, if we have a negative times a negative though, we are going to get a positive. We have parentheses negative 300 divided by 12. So the same rules apply for when you're multiplying integers as they do for dividing. So in the last question we had a negative times a negative, which gave us a positive, but in this question we have a negative divided by a positive, which is going to be a negative answer. So we get negative 25. And again, go ahead and use Desmos to check yourself after you're practicing these for the exam. Here, they're asking us to find the value of the expression. For this one, the name of the game is going to be order of operations. And I'm going to write this out here, our old friend, PEMDAS, just so we can have a reference here. Now we need to start with parentheses first. So parentheses, I'm going to start here. So negative 2 cubed, since this negative is inside the parentheses, it's going to mean negative 2 times negative 2 times negative 2, which is going to give me negative 8. So I'm going to keep that in there just to make things easier for myself. Then I'm going to write the rest of the equation exactly as it appears. Okay. Alright, so here, let's go ahead and take care of this. 3 squared right here is just going to be 9. But I'm going to leave this out here. So I'm going to write negative 9 times 5 minus 2 times negative 8. Okay. Now, we've got the same thing going on here. We can take care of both of these parentheses. So I have negative 9 times 5 is going to give me negative 45. I've got negative 2 times negative 8. A negative times a negative is going to give me a positive. Okay? And when I have negative 45 plus 16, that's going to give me negative 29. Okay. Reduce 16 over 144 to the lowest terms. Yeah, this is supposed to be a fraction. So I'll write it like this. So what we need to ask ourselves here is, what can I divide both 16 and 144 by? Well, there are a couple things. If you would like to start with what you know, we can start with 2. 16 divided by 2 is going to give me 8. And 144 divided by 2 is going to give me 72. Okay, now since these are both still even, we know that we can continue to divide both top and bottom here. So let's just go ahead and keep dividing by 2. It's going to be 4 over 36. And now we also know that here we could keep dividing by 2, but we know that both of these are divisible by 4. It's going to give me 1 over 9. And you can't divide that anymore. But the idea here is to keep simplifying until you get the fraction that is in the lowest terms, or meaning you can't divide any further. Convert to an improper fraction. Now, an improper fraction is all it is there is a larger number in the numerator than there is in the denominator. But this right here, then what they gave us is what's called a mixed number. Now I'm going to teach you a trick to creating improper fractions, and I think you're going to like it because it's fairly easy. So what I always do is I write a multiplication sign here and an addition sign here, and all we're going to do is multiply these two numbers together and add these two numbers together to get our numerator. So I've got 7 times 11 gives me 77, and then adding 5 gives me 82 on the top. And then what's on the bottom? Well, we're going to keep the same denominator as what we have here in the mixed number, so it's going to be 82 over 7. And since we can't simplify this any further, 7 is a prime number, this is all we have. Express 0.57 as a quotient of integers. This quotient indicates that we need to divide. So what does 0.57 actually mean? Well, since we have the 57 is after the decimal point, that means that we can take this and put 57 over 100. Something that helps me is if I think about this in terms of like a dollar amount. This would be 57 cents out of how much? Well, out of a whole dollar would be 57 cents. So this is going to be our quotient here. Perform the indicated operation and reduce the answer to its lowest terms. So I have a mixed number here divided by a fraction. Now, what I like to do is I want to turn this mixed number into an improper fraction. So we're going to use the technique that we just used in the other problem. Multiplication, addition. So I've got 4 times 1 gives me 4, plus 3 is 7 over 4, divided by 5/8. Now because we're dividing, we don't need to create a common denominator as we do with addition and subtraction with fractions, but when we divide, there is a trick that we always do, and it's called keep, change, flip. So we're going to keep the first fraction as it is. We're going to change the sign from division to multiplication, and we're going to flip the second fraction. Just flip it upside down. And now we have a new problem. Not really new, but we can multiply the top times the top and the bottom times the bottom. So I've got 7 times 8 gives me 56. And I've got 4 times 5, which gives me 20. Since both of these numbers are even, we know that they can be simplified even more. So, let's try. I know that we can divide both of them by 2. And when I do that, I get 28 on the top and 10 on the bottom. Still even. So let's continue to divide by 2. I get 14 over 5. What do we think about that? Well, 5 is prime, so I know that we're done. At a workshop on creativity, 1/4 of the participants are musicians, 1/3 are artists, 1/10 are actors, and the remaining participants are writers. What fraction of the group are writers? Okay, so here our best bet is to go ahead and write an equation. So let's start with what we know. 1/4 of the participants are musicians, 1/3 are artists, 1/10 are actors, and everyone else is a writer. So since we don't know how many writers, we're just going to make that X. What fraction of the group are writers? Okay, so in our equation here, for it to be an equation, we have to have an equal sign. But the whole group we know is going to be 1 whole. For it to be complete, it needs to all equal 1 whole. So, since we're adding fractions here, we know that we need to create common denominators. So, let's figure out what common denominator we can create. I've got a 4, a 3, and a 10. Well, let's think about, if I multiply them all together, 4 times 3 gives me 12, times 10 gives me 120, and that could work, but let's think about if we can make a smaller common denominator. Let's try 60. 60 is divisible by 4, 60 is divisible by 3, and 60 is divisible by 10. So I can change 1/4 into my denominator being 60. 4 times 15 gives me 60, and 1 times 15 gives me 15. Here I can change my denominator into 60. 3 times 20 gives me 60, so I'll multiply by 20 on the top as well. And then if I want my denominator to be 60 here, multiply by 6, and the top gets multiplied by 6 as well. Okay, awesome. So now that we've created common denominators, all we need to do is add the numerators. So I've got 15 plus 20 gives me 35. 35 plus 6 gives me 41. So I'm going to move over here. So I've got 41 over 60 plus x gives me 1. And to get x by itself, we can rewrite our equation as x equals 1 minus 41 over 60. Same thing, since we need to subtract by a fraction, I'm going to create a common denominator. So 1 is the same thing as saying 60 over 60. So we've got x equals 60 over 60 minus 41 over 60. And when I subtract just the top, you'll see that I get x equals 19 over 60. I think the whole point of this problem is creating the common denominators here. Okay. But with number 21, use the properties of exponents to simplify. So they've given me here 3 to the 8 over 3 to the 5th. Now, there is an exponent property that says that, I'm just going to use the 3 as an example, but it says whenever we have exponents in a fraction like this and they have the same base, we can actually rewrite this
as 3 to the m minus n, both in the exponent. This only works, however, if the bases are the same. So since the bases are the same here, we are going to use this property. So I can rewrite this as 3 to the 8 minus 5, which is 3 to the third. Just the same thing as saying 3 times 3 times 3. And you can type this in your Desmos calculator if you need to, but 3 to the third is 27. Simplify negative 19 to the 0. Per our exponent rules, anything to the 0, I don't care what it is, if it's negative, positive, big or small number, it's always going to be 1. So simplify. Okay, so this problem, something that you will need to know, one of our exponent rules that's going to be very important, a to the negative n equals 1 over a to the n. Okay, keep this in mind when we start working on this problem here. Okay, so what we need to do first is we need to group. We're going to use a grouping tool. So we want to group these numbers together, and then we want to group the x's together just to get our common bases next to each other. So I'm going to rewrite this as 4 times 5 times x to the 6 times x. That's all that I did here, okay? And I'm going to leave the bottom the same, 10 times x to the 9. Okay, so now, also this is an understood one, but I'm going to write it just so it's helpful for us. Oops. This is a 1. Whenever we have common bases, we can add their exponents if they're being multiplied. And same here, we can go ahead and multiply. So we're going to get 20 times x to the 6 plus 1 gives us 7 over 10 to the x to the 9th. Okay. So now what we can do here is when we have common bases that are being divided by each other, we can simply subtract their exponents. So I'm going to move up here. So I'm going to rewrite my coefficients here. I've got 20 times x, and the exponent, I can rewrite this as 7 minus 9. And I'm going to leave the 10 on the bottom. Now when I do this, 7 minus 9 is negative 2, so I can rewrite this as 20 times x to the negative 2 over 10. Okay, here's our rule right here. X to the negative 2 is going to drop into the bottom. So I'll rewrite this as 20 over 10 times x to the 2. And then 20 divided by 10 is just 2. So I'm left with 2 over x squared. That one, okay. Express 4.63 times 10 to the negative 5 in decimal notation. So currently this is in scientific notation. So I'm going to rewrite this. And all that we're going to be doing here is moving a decimal, because when you're multiplying by 10 to the anything, that's all you're really doing. So I'm going to take my 4.63 here. And because it's a negative exponent, I know that I'm going to be going to the left. My number is going to be getting smaller. So I'm going to move 5 times. So I'm going to go 1, 2, 3, 4, 5. My decimal is going to go right there. And then zeros can go in these little pockets that I've created for them. And my number is going to be 0.000463. And when we get an answer like that, that's the very reason why we have scientific notation. Keeps us from writing all those zeros. All right. Now in this one, we're going to go the opposite direction. So they give us a number, and we're going to put it in scientific notation. Now they give us 2,700. And for a number to be in scientific notation, the rules of scientific notation state that the first number needs to be between 1 and 10. So where would I put the decimal so that this number would be between 1 and 10? I'd put it right here, and it would give me 2.7. Okay, times 10. And now we need to ask ourselves, how many places should I move the decimal and in which direction so that I get 2,700? Well, go 1, 2, 3. And we're going to the right, so it's going to be a positive 3. Okay. Perform the indicated operations and express the result in scientific notation. Okay, so we're going to use the grouping method that we used earlier whenever we were simplifying. So we're going to group this with this, and then we're going to group the ones with the terms with the base 10 together as well. So let's just, all we're doing is rewriting. We're not solving anything yet. 4.5 times 8.2 times 10 to the third times 10 squared. Okay, and when we multiply this here, we get 36.9. And here we're going to use our exponent rules. When we have common bases multiplied together, we can simply add their exponents. So keep the common base, and then 3 plus 2 gives us 5. That is a 5. Okay. So now we have 36.9 times 10 to the 5. Is this in scientific notation? No. Be careful here. This number is not between 1 and 10, and we need it to be. So all we need to do is rewrite this. We'll need it to be 3.69. And when we do that, the number's getting smaller. Add to this number right here. It's going to be times 10 to the 6th. Okay, the mass of one hydrogen atom is 1.6 times 10 to the negative 24. Find the mass of 3,000 hydrogen atoms. Okay, so we need to multiply here. So we need to multiply the mass of the hydrogen atom, 1.6 times 10 to the negative 24, times 3,000. We could write times 3,000, but just to make it easier on ourselves, I'm going to rewrite this in scientific notation. So 3,000 in scientific notation is going to be 3 times 10 to the decimal would be right here. And I would move 1, 2, 3 to the right. So 3 times 10 to the third. Okay, same thing we did earlier. We're going to regroup the numbers right here. So 1.6 times 3 multiplied by 10 to the negative 24 times 10 to the third. Okay, when we multiply 1.6 times 3, we get 4.8. And we're using our exponent rules again. So negative 24 plus 3 gives us 10 to the negative 21. Okay, and we can rewrite this. This is already in scientific notation as 4.8 times 10 to the negative 21. How do we know this is in scientific notation? This number is between 1 and 10. And we've got the base 10 with the exponent here. So we're all good. We've got some conversion work here. So it says convert 100 feet to inches. Now for your exam, you do have a conversion chart available to you. So feel free to go ahead and have that handy as you're working through these problems. So let's start with what we know, 100 feet, and we're trying to go 2 inches. So how many inches are in 1 foot? Well, I do know that 1 foot has 12 inches. Okay. And when I do that, when I put the feet on the bottom and I have feet on the top already, my units will cancel out and I'm left with inches, which is what they're asking for in the problem. So now all that's left is I just multiply. 100 times 12 gives me 1200, and inches are the units that I have remaining. So convert this number from kilometers to centimeters. All right, so I'm going to rewrite it. Okay, and remember our little device here is King Henry doesn't usually drink chocolate milk, or whichever version of that you prefer. And we're starting with kilometers and we're going to centimeters. So we're going to start here and we're going to end up here. So that's going to be 1, 2, 3, 4, 5 to the right. So we're going to do the same thing here. 1, 2, 3, 4, 5. So our answer is going to be 37 centimeters. Convert 26 centimeters to inches. Round your answer to 2 decimal places. Okay, so let's start with 26 centimeters is what we have. We want to go to inches. Now, if you'll take a look at your conversion chart, there is a conversion on there that says 1 inch equals 2.54 centimeters. So I'm going to put the centimeters on the bottom because I want the centimeters, the unit of centimeters, to cancel out. So 2.54 centimeters over 1 inch. And the centimeters will cancel. And all I need to do is divide. So when you type this in your calculator, 26 divided by 2.54, you're going to get quite the decimal here. That's okay, just write off the first couple digits, and then we can round to 2. The question wants us to round to 2 decimal places. So here's 1, 2. We look to the right, this is larger than 5, so this is going to become a 4. So 10.24 inches. Okay, to measure a football field, would the best units be millimeters, meters, or kilometers? Now for this one, rather than just guess, if you will look again at your conversion chart, you'll notice that there is a conversion that says 1 yard equals 0.9 meters. Do you see it? Yeah. So 0.9 is very, very, very close to 1. So we're going to say meters in this case. This is one of those ones where on the exam, it's going to be helpful for you to have that conversion chart right in front of you. Okay. Convert 16 milliliters to teaspoons. So we're going to start with what we know, milliliters. And again, on your conversion chart, there is one that says 1 teaspoon equals 5 milliliters. Okay, milliliters is going to go on the bottom. Milliliters will cancel. And when I type 16 divided by 5 into my calculator, I get 3.2 teaspoons. Convert 26 ounces to grams. Okay, so we'll start with 26 ounces. And again, we can look at our conversion chart. And I'll write this one up here for you. But it says 1 ounce equals 28 grams. I'm so thankful for conversion charts. So the ounces are going to go in the bottom. And we've got 28 grams. And the ounces get canceled, and we can just multiply 26 times 28, which gives us 728 grams. Let's keep moving forward here. Convert 68 degrees Fahrenheit to Celsius. Okay, so again, on your formula chart, there are a couple of formulas you can choose from. It doesn't really matter which one you use as long as you put the correct numbers in for the correct variables, but I'm just going to pick one. I'm going to go ahead and use this one. F equals 1.8 C plus 32. So they gave us Fahrenheit, so we're going to put that in. 68 equals 1.8 C plus 32. We're going to isolate this variable by subtracting 32 from both sides. This cancels out. We get 36 equals 1.8 times C. I'm going to rewrite this up here. Then we can divide by 1.8 on both sides to get C by itself over here. And when we divide 36 by 1.8, we get 20. 20 degrees Celsius. The prescribed dosage of a drug is 10 milligrams per kilogram daily. How many 400 milligram tablets should be given each day to a patient who weighs 180 pounds? Now, here, let's pay close attention to our units here, okay? So the dosage of a drug is milligrams per kilogram. The tablets are in milligrams, and they give us the patient's weight in pounds. So we're going to start by taking the patient's weight and putting it in kilograms, just so we can help ourselves out a bit, okay? So we can take 180 pounds, and your conversion chart is going to tell you that 1 pound, I'll write it up here for you guys, 1 pound is equal to 0.45 kilograms. Okay, so pounds are going to go on the bottom. Okay, and pounds cancel. And when we multiply, we get 180 times 0.45. So it's 81 kilograms. So this is how much the patient weighs in kilograms right here. Okay. Now they want to know how many tablets each day. Well, first, let's find out how many milligrams of the prescription they're going to need. So they should get 10 milligrams per 1 kilogram daily. Okay, so we've got kilograms here, so we're going to set up a proportion. All a proportion is an equivalent fraction. We have matching units on the bottom, and we're going to have matching units on the top, but this is what we're searching for, so we're just going to call it x, okay? So to solve, we're going to cross multiply. 81 times 10, I'm going to write it over here. 81 times 10 is going to give us 810. 1 times x is just x. So x equals 810. But 810 what? Well, our units are going to match, so it's going to be 810 milligrams. Now, what did we just find? We found that the patient who weighs 180 pounds needs 810 milligrams. But the question is asking how many tablets? And each tablet is 400 milligrams. So we're going to divide. We can take 810, which is the total milligrams they need, divided by the milligrams in each tablet, which is 400. And when we divide this, you're going to get 2.025 tablets.